Okay, lesson 2. So moving right on, we're going to talk about volume of prisms to be exact with this. Technically also I should add on here and cylinders. However, cylinders are actually kind of a form of a prism. The formula is technically the same, but I give you 2 separate ones just so that we're clear on them. So let's talk about volume. So if you recall, you have learned before about area and perimeter. You've probably learned about volume as well, but it might have been a while. So that perimeter of an object is if I were just to measure the length, right? I'm talking about the length of something. I'm just taking a measuring stick and measuring, okay, this is 8 inches by 11.5 inches or whatever, yeah? Area is talking about how much area a flat surface covers, right? So I would do, if you recall, for the area of a rectangle, which we're going to talk about in a bit, that's the length times the width, boom, that's our area. Now that's measured in square units. Really, literally, how many squares I could fill. 1 inch by 1 inch, for example, 1 centimeter by 1 centimeter, whatever I'm measuring in, how many of those little squares could fit, that's area. Now volume is 3 dimensions. So volume is the number of cubic units that will fit in a solid. So this is easy to visualize if our solid shape is a cube. Literally, the volume is, if I were to count all of these cubes, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then I have 3 total rows of that. So this cube here has 9 times 3, so 27 cubic units is what this one would measure. And then again, we can do, these are just getting bigger and bigger. These all have 27 cubes. So it's easy to visualize when our shape is a cube itself, but this still applies even when our shape is not a cube. So you can see this is kind of the top view. This is kind of the visual of filling a cylinder with cubes. Now around the edges, we don't have exactly a cube, right? We can see it's kind of cut off, but it's part of a cube. So we could say, oh, well, it's a half of a cube. Yeah, we can actually still do that. And then these cubes just stack up and fill our object. And then we can say there is this many total cubes with the likelihood that in a shape like this, our answer is going to be a decimal or a fraction of a number of cubes. Now, this isn't very important for us right now because we're online and we don't have to write units. But what this means is, again, inches squared is for area, inches cubed is for volume. 2 is a square, 3 is a cube. Yeah, I know that seems weird. Normally we would think 4 for square, I know, but hopefully by now we know that we can read this as inches squared, inches cubed. That's going to be our units. Again, it could be in centimeters, it could be in meters, it could be in feet. But if we're talking about volume, there is a little 3 there, and that's because volume is 3 dimensions, right? Area is 2 dimensions, it's flat. So that's why area has a little 2 and volume has a little 3 because volume has to do with filling something up. That's 3 dimensions. So we have some formulas for this that we're definitely going to need to make sure we write down. So again, it really is technically the same formula, but I'm going to give you 2 separate ones. So volume of a prism. So remember, this is mostly rectangles with 2 sides that are a special shape. So the volume of a prism is capital B times H, where B is the area of the base of the prism. You need to make sure you write this down as well, because if you don't know what B represents, then you don't know what to do. Now, we can have special prisms. We can have a hexagonal prism. We could have a nonagonal prism. Yeah, crazy shapes. But we are only really going to be looking at 2 because the area formulas are much easier. The area formula for a hexagon is kind of complicated. So we want to write these down as well because we're going to need these formulas to calculate the B in order to do the volume. So area of a rectangle, if you don't recall this, is length times width or base times height, however you want to call it. That's just these 2 right here, yeah? Length times width, that's the area of a rectangle. For a triangle is actually half of a rectangle. So 1/2 base times height, or again, 1/2 length times width. For whatever reason, in my own mind, for a triangle, I use base and height, and then for a rectangle, I use length and width. It literally means the same thing. Now, a cylinder's formula, this is again for volume, is pi r squared times height, where r is the radius of the circle and h is the height. Now, we took this part out when we were talking about circles in the last unit, but this formula right here, pi r squared, that is the formula for area of a circle. So this technically is the same formula. It's just that B is a circle. And so this is the formula for area of a circle. But again, I'm just going to give you those two separate formulas. They technically are the same thing. You want to make sure you have all this written down, super important. But all we are doing is plugging right in. We just have to be able to identify the shape, identify the base, and then go from there. So let's copy over our formula. Again, I would not necessarily recommend you copy this picture. You could, it's just a little tricky to copy. Now, I kind of skipped here. Hopefully we know that this is a prism and not a cylinder, at least. We have two bases that are what shape? What are these two shapes? Triangles. So these are our bases here. Again, the two shapes that make up the two sides like that, the rest are rectangles. We care about those triangles. So this B then needs to be the area of that triangle. That's triangle. And then we have the height. So what we mean is, if you can imagine standing this up on its bases. I know we do say height, but right now this prism is actually laying down. When we say height, we specifically mean if you were to stand it up on those triangles, what would the height be? So looking at our numbers here, what would the height be if we were to stand this up? 8 is going to be the height. You can see that's going backwards. Again, take this prism, tilt it up. That would be a height of 8. So let's go ahead and replace here. We need the area of the triangle. So let's go ahead and do that. The area of our triangle is formula 1/2 its base times its height. So what is the base of this triangle? Ignore everything else. What's the measurement of the base of this triangle? 6. Hopefully we got that there. Oops, 1/2. The base is 6. What's the height of the triangle? 5. This is the height of the triangle. So 1/2 of 6 times 5, that is 15. That is the area of the base that we are then going to plug in to B. So our B is 15. We already determined what the height was. What was the height again? That should be 8. Again, I know it looks like it's sideways. You wouldn't necessarily call this a height, but when you tilt it up, that is the height. So our volume is 15 times 8. Whoa, what did I just do? So let's grab a calculator for that. Our volume is 15 times 8. We have 120. Now, they don't tell us if this is inches or centimeters or whatever. So we can call this cubic units, because we don't know what the units are. Or you can say units, sorry for my handwriting here, cubed. But that's our answer. Again, if it said inches or centimeters, we would need to kind of include that, but that's okay. Now, because I'm running out of time here, because I'm going to start our WebEx here in a second, let's try this one real quick. So find the volume of the solid here. So we need to determine, what is this? Is this a prism or a cylinder? This is a cylinder. So we are going to use that formula for volume, which was pi r squared times the height. Once again, the height is if we were to tilt it straight up onto its bases. The circles are its bases, tilt it up, that's the height. So between 4 and 12, what would be considered the height? 12 is considered the height because, again, if I go tilting upwards, that 12 would tilt up and become my height. We should know that this is the radius because the definition of radius is from the center to the outside. That's the radius. So all we gotta do is plug in. We have pi, which is the button on your calculator. R is 4, but we need it squared. Be very careful with that. Just R is 4, but the formula has R squared times the height. So I need to look at your homework. Sometimes they leave it in terms of pi, and here's what I mean. Let's go ahead and multiply that, just that out. This is 12 times 4 squared is 192, but we also have pi. There are some times where that's how you would leave the answer. We call this in terms of pi because pi is still in your answer. But do you remember what number pi actually is? It's 3.14159, it goes on forever, right? It's also a button on your calculator. So if I go 192 pi, this is actually 192 times about 3.14. So this is actually 603 centimeters cubed. So again, I need to check your homework. It's possible they want you to leave the answer like this. If they do, it would be a multiple choice question because you can't type pi as far as I recall. Or it would be this if they don't want you to leave it in terms of pi. So we're going to practice this a bit more tomorrow. I kind of rushed this at the end because I recorded this video literally right before our WebEx. If you can see, our class starts in 2 minutes. So we're going to practice a bit more tomorrow. I just wanted you guys to get some practice here since the first lesson you did was pretty simple.